Factoring by grouping. So, not all polynomials can be factored by grouping, including ones that can be factored, but this is how we factor by grouping. We'll split the polynomial into smaller polynomials. This isn't any math, this is just looking at it as two smaller pieces. Then for each of those, you'll factor by greatest common factor. So if you don't remember how to factor by greatest common factor, go back, watch the video on factoring by greatest common factor, do some practice with that. Then factor by greatest common factor for the larger polynomial. And if this went well, then the greatest common factors for the smaller polynomials will yield the greatest common factor for the larger one. So I'm going to split this into two smaller polynomials. So here, the greatest common factor between these two is x squared. What's left over is we're going to divide this by x squared, divide that by x squared, and we'll get x plus 3. For the second one, these are both divisible by positive 5, so we'll divide by positive 5, and that will give us x plus 3. Now, if we have done these right, then these will match. So what we're going to do is we'll use x plus 3 as our greatest common factor, and we'll divide by x plus 3 for both of them. And when we divide by x plus 3, what we're left with is the binomial x squared plus 5. And that is our factored expression, factored by grouping. If you multiply this out, you would get back to the original, but we're not doing that. We're trying to factor. Factoring and simplifying polynomials are opposites. So here, let's try it again. We're going to factor each of these binomials. So this one, it looks like they're both divisible by xy. And the second polynomial, it appears that the second polynomial, they're both divisible by negative 6. So I'm going to divide the first one by xy, divide by xy. So you get x squared divided by x is x, y divided by y is 1. Negative 7 divided by 1 is negative 7. X divided by x is 1. Y divided by y is 1. We're dividing by negative 6 here. And negative 6x divided by negative 6 is positive 1x. 42 divided by negative 6 is negative 7. Now we've done it right because you see x minus 7 in both cases. So we'll divide by x minus 7 as we factor out x minus 7. And what's left is xy minus 6. All right, more examples. So this one is a little trickier because it's not a 4-term polynomial, it's a 6-term polynomial. But I'm going to look at this as two separate polynomials. Now, here we have a cubed. It goes into both of those. And here there is no greatest common factor. The greatest common factor is 1. So that's fine. A squared plus 2a plus 1. And then for the first one, we have a squared plus 2a plus 1. That's by dividing this by a cubed, by dividing this by a cubed, dividing this by a cubed. Now, we do have the same thing twice. So we're going to say a squared plus 2a plus 1. And what's left over is a cubed plus 1. Now, technically, this is not done. This is not done. The blue polynomial can be factored further, but the blue polynomial is not factored by greatest common factor, so we'll worry about, by grouping. It's using splitting the linear term. That's not what we're worrying about now, but the process still works. This is not done, but we got most of the way there using this. And lastly, here, this is a real mess. Let's see whether we can do this successfully. So x squared plus y squared, x squared, y squared, z squared, x, y squared, z, t. So they have a single x, two y's, and a z in common. So I'm going to divide by x, y squared, z. Divide by x, y squared, z. And for the second one, they don't have an x in common, they have a y cubed in common. And I think that's it. So this is what we're doing. Now, when we factor the first one, x squared divided by x is x, y squared divided by y squared is 1, z squared divided by z is z. For the second one, x divided by x is 1, y squared divided by y squared is 1, z divided by z is 1, and then we're left with t. Now, for the second one, x y cubed z divided by y cubed is x z, and y cubed t divided by y cubed is t. So now they match, so that means we'll have xz plus t as our greatest common factor, and what's left over is xy squared z plus y cubed. Now you might notice that there's actually more that we can do here because this has a greatest common factor of y squared. So I'm going to do that as well. Make this y squared times xz plus y. And we still have xz plus t. So this problem used both factoring by greatest common factor as well as factoring by grouping. Thank you.